This is Britt Caswell with another video on examples. So in this example 5 from lesson 1-2 in the SavvasRealize Algebra 2 textbook. In today's example, we are looking at identifying transformations from an equation. So theoretically, we can look at an equation and figure out what transformations are happening. I'll be using this graph to help me compare it as well. So I always tend to look at kind of what the parent function is and then look for what is changing within that function. Okay, so if you notice this is an x squared function, or as we call it, quadratic. Here's where they've written out the quadratic. And so we need to kind of compare and contrast what's happening. So from the original equation, I see that there's a negative, and I see that there is a 1/3. Oh, that was a terrible arrow. But it's right there, the 1/3. And so each of those is describing its own type of transformation. So this negative sign, it is outside of the grouping symbol. Okay, that means that it's going to be a vertical change. Okay, and if ever you have something that's negative, that's going to be a reflection. Alright, so having a negative outside the grouping symbol is a vertical reflection. Alright, and then inside the grouping symbol, okay, anything happening inside of a grouping symbol is a horizontal change. Alright, now remember, horizontal stuff feels a little backwards, okay? So if you're multiplying to the x, this is going to be either a stretch or a compression. So here, if a is greater than 1, it's going to be a compression. I almost started writing stretch there because I'm not used to going backwards. And then if a is between 0 and 1, you should get a stretch in the horizontal direction. Okay, so here a is 1/3. That is between 0 and 1, so this is a horizontal stretch by a scale of 1/3. Okay, so let's go and take a peek-see over here. So these are the two graphs, right? So this blue one lines up with x squared. It's our normal parabola. So if you notice, between the blue and the red, it flipped upside down. That's our vertical reflection. And then if I use my little creepy hands, if I'm doing my horizontal change here with my creepy hands, and I pull the graph out like this, I'm stretching it horizontally, and that's what that 1/3 is doing right there. Is it's pulling our little Laffy Taffy graph to the side. Let's try another one. So now for this one, again we're dealing with our parent function, the normal parabola of x squared. Okay, and looking at the equation, I see two things that have changed. I see this -4, and I see this +5. So let's start with the -4. So the -4 is inside the grouping symbol, so it's a horizontal change. It's addition or subtraction, which is telling you that you're having a translation. Alright, now when you're subtracting 4, it's actually going to take you to the right by 4. Okay, because remember, those feel backwards inside the grouping symbol. And then if we look at the outside here, it's happening outside the parentheses, this +5. So that's a vertical change. It's addition or subtraction, so again, that's a translation. And then since it's a +5, that means that it's going to be going up by 5. And so if we compare our two graphs, notice that from the vertex here to the vertex here, it did in fact go to the right by 4 and then up by 5. Their scales are different on their axes. Notice this counts by 2 and that counts by 4s. But there it is. That's how you can see it physically on the graph as well. Alright, so now let's take a look-see on this next one. They're gonna have us graph the new function as well. I'm gonna rewrite the function here to the side. Oops, it's a G. That way it's easier for me to draw my little arrows and tell us what's happening here. Alrighty, so this first one. There's a 1/2 being multiplied outside the function, so it's a vertical change. Because it's multiplication, it's either a stretch or a compression. Now with the vertical stretches and compressions, if a is bigger than 1, it's a stretch. And if a is between 0 and 1, it's a compression. So that 1/2 there is between 0 and 1, so this is a vertical compression by a scale of 1/2. And then if I look here at this +3, it's inside the grouping symbol, so it's a horizontal shift. It's addition or subtraction, so it's a translation. And then it's a +3, which is saying we're going to go to the left by 3. So when I go to graph this, first I'm going to graph the compression, and then I'm going to do my translation. So let's take a look-see. So whenever we have a vertical compression, all that we need to do is take each anchor point that we want to use and cut its distance from the x-axis in half. Alright, so here this point is at 2. I'm going to make it at 1. Here it's at 4. I'm going to put it at 2. And hopefully, if I know how to draw well enough, you should get a graph that looks roughly, like very roughly, that way. Okay, here this one goes up to 2, so I'm going to go up to 1. This one goes up to 4, so we're going to drop it down to 2. And 6 is going to go to 3. Just right there. So now we have vertically compressed our graph. Okay, if I draw my little creepy hands, which are from video to video getting worse, and I were to push on the top and the bottom of the graph, it's going to compress that graph. And so now we're going to deal with the translations. Okay, it says that we're going to do a horizontal translation to the left by 3. So I'm going to take each of my anchor points and scoot them bad boys over by 3. 1, 2, 3. So there's my right hand or left hand side. 1, 2, 3. 1, 2, 3. And there goes very terrible drawing of my right hand side. So now the green is the solution here. Alrighty. Another one. So my function here, okay, it's an absolute value function. So I started us out with an absolute value graph. Here I have a negative being multiplied to the parentheses. Alright, that's automatically a reflection, right? And because it's outside of this grouping symbol, it's a vertical reflection. So it's going to be flipping this graph all upside down. Kind of like Will Smith used to do. Alright, and then this +2, it's outside the grouping symbol, so it's also vertical. It's addition or subtraction, so it's a translation. And then because it's a +2, it's going to be going up. Alright, now our kind of order of operations with graphing this, I do my reflection first, and then I'll translate. So first I need to flip this upside down. So all that I do is I look, this one has a slope of 1. Now it's going to have a slope of -1. This part had a slope of -1. Now it has a slope of +1. And very, very roughly there, I've reflected it. And then now we're going to take that reflection and I'm going to translate each point up by 2. So 1, 2. So now this lavender one is the solution. Although really when I say solution, the problem wasn't really asking for a graph, right? They're asking for the transformations. So the actual answers to the questions being asked are these things that I've written on the sides. But the graph is there too as well. Alrighty, and so that is example number 5. Until next time.